Question number 7. It
Yeah.
says the sector has an angle of 1.19 radians and an area of 20.8 centimeters square. Find its radius and the perimeter. So first of all, we should know the formula for finding the sector area and arc length, right?
Yeah.
So I'm just making a sector. This is actually a circle, got it? And it's a center of the circle. This one. So if I make any two radii in the circle like this, then this part of the circle is called the sector. Got it? Yeah, this is actually sector. And the angle between these two radii is called the sector angle. Means this one. This is, say, this is theta, right? And obviously this should be radius r and it should be r as well. What is arc length? Arc length will be A to B. And say center is O, right? So finding the arc length, I'm just writing the formulas first. Arc length is equal to the sector angle divided by total angle of the circle, that is 360 degree or 2 pi, right? If you are doing in radians, you have to write it 2 pi. Otherwise, if in degrees, then you should write in degrees, right? 360 degrees. So sector angle is over 360 degree multiplied by arc length, because we are taking actually part of the circle. So complete circle circumference is 2 pi r, right? So if we multiply this part, so that's why this will be multiplied by 2 pi r. And this is actually the part, right? Sector angle over 360 degree. Got it?
So does this formula stay the same?
Yeah.
Okay.
For radians, it becomes this. Sector angle like theta, 2 pi, and this is 2 pi r. Got it? So you can cancel them out, and the arc length will be theta r. But theta must be in radians.
Yeah.
For this formula. Right? Okay, next is the area of the sector. Area of the sector is the region that bounded by this sector. Got it?
Yeah.
So its formula is almost similar. This part is similar. This part is very same. Just you have to change this one, 2 pi r, with the pi r square, right? So area of sector will be equal to, again, sector angle divided by 360 degree. Multiply by this time will be multiplying with the area of the circle. Area of the circle is pi r square, right?
Yeah.
So if you are working in radians, like in this question, because the sector angle given is in radians, right? So this 360 becomes 2 pi. Got it? Sector angle theta and pi r square. So pi and pi cancel, and we're left with what? 1 over 2 pi theta, 1 over 2 theta r square. So this is actually the area of the sector formula. Got it? If you are working in radians. I'm going to use. Yeah?
1 over 2 come from? The 1
because the 2 is the denominator. So actually I have written this 2 separately, 1 over 2. Or you can write it as theta over theta r square over 2. Same thing.
Oh, yeah.
Right? Okay.
Yeah.
So in this question, we have a sector angle that is in 1.19 radians, and the area of the sector is also given to 20.98. So we need radius. So which formula should we use? Because the area is given, so that's why we should use the area of the sector formula, right? And I'm doing here part A. Area of the sector is 1 over 2 theta r square. This formula is applicable when the theta is in radians. Got it? So 1 over 2 theta is 1.19, r square as it is, because r is unknown here. Area is 20.8. So I'm replacing this A with 20.8. Now you can take this all the values to the other side. 2 will multiply here and 1.19 divide this whole thing, right? And it's equal to the r square. Now you can take the square root of both sides. So this will give you the value of r, right?
Yeah.
So square root of 20.8 times 2 divided by 1.19, right? So the radius will be 5.9125. And if I write answer in 3 significant figures, this answer will be 5.91 in centimeters. Got it?
Yeah.
Okay, next thing is to find the perimeter. Perimeter of what? Perimeter of the sector, right? Okay.
Yeah.
If you say this sector, perimeter will be, sorry.
Yeah.
Yeah. Perimeter will be this. This arc length plus R plus R. Got it?
Yeah.
This total length is basically the perimeter of the sector. So what should be the formula for the perimeter? Arc length AB plus 2R. R plus R, 2R, right?
Yeah.
So I'm doing part B here. Yeah. Perimeter of sector. It is arc length AB, or we can say arc length plus 2 times radius, right? How to find the arc length? Arc length formula is theta r, right? So theta r plus 2r. Now you can set the values. What is theta? Theta is 1.19, right?
Yeah.
And r is 5.9125 plus 2 times. I'm taking the value that has more significant figures for the accuracy. So 5.9125, right? Now you can calculate this, and even I can use the calculator value as well. 1.19 times answer, then plus 2 times answer, right? So this is actually the perimeter of the sector, 18.86. And then we have 10, right? So in 3 significant figures, this answer can be written as 18.9 in centimeters, right?
Yeah.
Perimeter is a length, so that's why the units must be centimeters. Got it?
Yeah.
So this was actually complete question, right?
Yeah.
Okay, in question number 8, we have this figure. The end wall of a building has a shape illustrated, right? So this is actually the shape of an end wall. And you can see its shape. This shape has a rectangle. And what about this? This is AB, which is actually arc, right? AB is an arc. And obviously arc is a part of the circle, so it must have a center, right? And it says the arc center is at C, at this point, right?
Yeah.
So find alpha for 4 significant figures. So what is alpha here? Alpha is this angle, right?
Yeah.
And theta also should be found in part B. In C part, we have to find the area of the wall. Okay, we'll do first A part. In A part, we need alpha. Okay. As center, and obviously it's a rectangle, these two lengths are equal. So it means these two triangles, this one, this triangle, and this triangle, they must be congruent. Congruent triangles mean exactly same, right? Equal lengths. So if it is 5 centimeter, this must be 5. If it is length is equal, already mentioned by the cuts. So this length must be equal as well, right? Got it? Okay. Another thing should be noted that this total length is given, which is 30 meters. So this half length must be 15 because the two lengths are equal. So obviously 30 must be divided into two parts, equal parts. So this length will be 15. Clear?
Yep.
Half of 30. So we have a right angle triangle. If I label it as D, we have a right angle triangle BCD. Like this, right?
Yep.
This is C, this is D, and this one is B. And I'm mentioning the lengths 5, and this is 15. What we need alpha in degrees, obviously mentioned here, right? And answer must be in 4 significant figures. So I will follow this part, this instruction as well. Okay. So how to find this angle, as it's a right angle triangle? Got it?
Yeah.
So we can use the trigonometry ratio here. The two lengths are given 5 and 15, and they are opposite and adjacent sides, right?
Yeah.
So that's why we should use tan here. So tan alpha equals opposite side is 5 over adjacent side is 15, right? So alpha will be equal to tan inverse of 5 over 15. Got it?
Yeah.
So tan inverse of 5 divided by 15 inside this bracket. So we get 18 point, or the answer must be 4 significant figures. So 18.43.
Yeah.
In degrees, right? Okay,
Yeah.
next thing. Next thing is finding theta. Theta is in this triangle. You can see that. Yeah, this triangle. As they are congruent triangle, one way is to find it, as this must be alpha as well, right?
Yeah.
Because both are, this is the actually radius of the, yeah, these are radii of this sector, right?
Yeah.
So if it is alpha, the theta can be found by just subtracting these two alphas from 180 degrees, because this is the half rotation, this one, right?
Yeah.
So doing part B now. In part B, the sum of all angles on a straight line must be equal to 180 degrees. They are adjacent angles on a straight line. So alpha plus theta plus alpha must be equal to 180 degree, right? So 2 alpha plus theta equal to 180 degree. Theta will be equal to 180 degree minus 2 alpha, right? Now you can insert the value alpha. The value alpha is 18.43. Got it?
Yeah.
So 180 minus 2 times this. So we get 143.1. Answer must be in 4 significant figures. So that's what I'm writing. 143.1, right? So theta will be equal to 143.1 degrees, right?
Yeah.
So this is alpha, and this one is beta, this one.
Yeah.
In part C, we have to find the area of the wall. So wall consists of two, because we cannot find this, if we take this rectangle, so we cannot find this area, because this is not actually sector. So we'll be mentioning which part is the sector, right? So I'm mentioning here, this is basically sector. This one, right?
Yeah.
And the leftovers part of this wall will be two triangles, right? And both triangles are congruent triangles. So if we find the area of one triangle, we can multiply the area by 2 to get the total area of these two triangles, right? And the sector area can be found by using the formula. Got it?
Yeah.
So in part C, area of wall will be equal to what? Area of sector plus 2 times area of triangle. I'm just mentioning the name, triangle BCD, right?
Yeah.
Okay, how to find the area of sector? Area of sector, because the answer, actually the angles given are in degrees, so that's why I'm using the formula that has degrees, or alternatively you can convert the degrees into radians. Then you can use the formula 1/2 r theta, r square theta, right? Otherwise, we can use this as one sector angle. What is the sector angle of this? Is theta, right? Which is 143.1 divided by 360 degree, right?
Yeah.
Multiply by pi r square. What is r? R is unknown, so it means we should have found r before doing this.
Yeah.
So I'm finding r. How to find? Either you can use the Pythagoras theorem or the algebra or the trigonometry ratios, right? So I'm finding the r here first. So r square is equal to 15 square plus 5 square. Now taking square root of both sides, we get r. It is 15 square plus 5. Sorry. Square root of 15 plus 5 square. So we get this 5 into square root 10. I'm using the exact value. I'm not converting to decimal, right? So this is 5 times square root 10 whole square, pi r square. Then plus 2 times area of the triangle. What is the area of triangle here? 1/2, because it's a right angle triangle, so we can take 1/2 base into height. Got it? So 1/2 base, base is 15 and height is 5. Got it? Okay. Now you can use calculator for this whole expression. (143.1) divided by 360 multiply by pi into 5 into square root 10, then whole square plus 2 to cancel, so 15 into 5, right?
Yeah.
So it is 387.19577. So 387.19577. Okay, we can write this answer in, I think we should write it in the 3 significant figures. So it will be 387 meters square. So this is the area of the total wall, right?
Yeah.
Okay. So this is question number 9. It says the cone, this cone, is made from the sector, this sector. Basically, when you join these two radii together, which radii? This. You'll end up a cone, right? So if you end up with the cone, this cone is actually mentioned here. So if you see that this must be the slant height, right? And this 12 must be the arc length of this cone. So we can say, because when you join these lines, this must be the circumference of the base, right? So this is actually 12. Got it?
Yeah.
And what about these lengths? this must be the S, the slant height of the cone, right?
Yeah.
Okay. So correct the three to the significant figures, the slant length S. So S is required, so we can find S by using a right angle triangle. I'm mentioning here, this is actually a right angle triangle. Got it?
Yeah.
By making this right angle triangle, it's actually part of cone, obviously. Which length is this? This is the S length. This is 10, right? What about this? This is actually the diameter of this radius, sorry, cone. And this length must be half of the diameter. So it must be 6, right?
Yeah.
So we can find S because 2 lengths are given of the right angle triangle. Third is unknown. So we can use the Pythagoras theorem. So using Pythagoras theorem. Right? So according to the Pythagoras theorem, the opposites, the hypotenuse square equal to the sum of the squares of other two sides, 6 and 6 square plus 10 square, right? So taking square root of both sides, and this will give you the value S. Got it?
Yeah.
So square root of 6 square plus 10 square, and we get 2 times square root 34, and answer must be in 3 significant figures, so it must be converted to decimal. I'm pressing this button, yeah. It is 11.6619. Answer must be in 3 significant figures, so only these first 3 digits should be taken, right?
Yeah.
So 11.7. So this 6 will be incremented by 1 because of the 6 after it. So 11.7 centimeter will be the value S, right? Approximate value. Part B, the value of R. So what is R here? R is exactly equal to S, right?
Yeah.
Yeah. R is exactly equal to S. We have that. So it will be 11.7 as well, right?
Yeah.
Part C, the arc length of the sector. So arc length is this. So this actually length is required. So we'll be using the formula. We need actually theta here, the sector angle. Got it?
Yeah.
To find arc length, but we don't have the theta. Another way is to finding the circumference, because this arc length is actually circumference of this base of the cone, right?
Yeah.
So if we find the circumference of this circle, this will be exactly equal to the arc length of this. Got it?
Yeah.
So in C part, I'm doing finding circumference, or we can say arc length of sector equals circumference of base of the cone. Right? So obviously its circumference is 2 pi r. 2 into pi. What r should be taken? Not this one. R should be 6, because this is actually the radius of the cone, right?
Yeah.
So 2 into pi into 6. So it is 12 pi or 37.699. In 3 significant figure, this answer will be 37.7 in centimeters. Got it?
Yeah.
Okay, the last part, the sector angle theta in radians, right? So now we have what? We have the radius, we have the arc length as well It is not 12,
Yeah.
sorry. It is the circumference, C, right? This one.
Yeah.
So this length is actually 37.7. And we'll be taking a more accurate one, 37.699. Got it? Okay. So next is part D. So I need sector angle. The formula for, because I have the actually arc length. The formula of arc length is S is equal to R theta in radians. If theta in radians, right? So S is given, which is arc length. It is 37.699. The radius of this sector is R, and its value is this.
Yeah.
So 11.6619, right?
Yeah.
Then multiply it with theta. So theta will be equal to 37.699 divided by 11.6619. So 37.6619. So we get 3.23. So theta will be equal to 3.23. Yeah, in radians, right?
Yeah.
Again, answer must be in three significant figures. That's what I'm writing 3.23. Got it?
Yeah.
Okay. Okay. Yeah, it says a nautical mile and is the distance on the Earth's surface that suspends an angle of 1 minute. 1 minute is actually 1/60th part of the degree, right? Of 1 degree.
Yeah.
Of a great circle that is measured from the center of the Earth. A knot is a speed of 1 nautical mile per hour. So knot is a speed. Got it?
Yeah.
So basically 1 nautical mile is actually the distance, right? You can see if the distance covered, obviously, because Earth is almost a sphere, right?
Yeah.
So when you cover a distance, basically you cover the distance in arc, right? This distance is not exactly straight line distance. It must be curved distance, right? So this curved distance is represented on the diagram is PQ. And this angle that equals to what? 1/60 degrees, right?
Yeah.
So the distance covered when you cover this angle 1/60 degree, this distance along an arc will be PQ or 1 nautical mile, right?
Yeah.
So given that the radius of the circle Earth is 6370 in kilometers, show that 1 nautical mile is approximately 1.853. So 1 nautical mile, this actually distance covered in from P to Q. Got it? So we have to find the distance PQ, obviously. So PQ is an arc length, and obviously it must. So PQ is an arc length, and it is equal to the sector angle over 360 degree, because sector angle is in degrees, right? Multiply by 2 pi r. So sector angle this time is in 1 minute, which is 1/60 of the degrees, right?
Yeah.
Over 360 degrees, multiply by 2 pi r. R is 6370, right?
Yeah.
Okay, and also the answer must be in kilometers, so that's why I'm taking the radius in kilometers, right? Okay.
Yeah.
Let's calculate. It is 1/60. And then 360 in the denominator, then multiply by 2 pi into 6370. So we get 1.853 exactly. Yeah. 2958. And approximately this must be equal to this, right? 1.853. So 1 nautical mile equals 1.853. Got it? 1 nautical mile is actually equal to PQ. Got it? 1 NMI, right? Kilometers. Okay, in part B, calculate how long it would take a plane to fly 2130 kilometers from Perth to Adelaide if the plane can fly at 480 knots. So 480 knots is actually speed given.
Yeah.
Also the distance given, right? So when the
Yeah.
speed and distance given, we can find the value of t, time, right?
Yeah.
So what is the formula of time? Time is equal to distance over
Distance.
speed, right?
Yeah.
Okay. Distance is in kilometers and speed is in knots.
Yeah.
And obviously it's in mile per hour. As this distance in kilometers, so the speed must be in kilometers per hour. Got it?
Yeah.
So I'm finding the speed first. So I'm converting the speed into kilometers per hour. So the speed is actually 480 knots. Knots mean what? 480 times 1 nautical mile, right?
Yeah.
So first of all, converting knots into kilometer per hour, right? So I'm writing here knot and multiplying this thing with the factors. Yeah. Writing knot here, 1 knot equal to what? 1 N nautical mile, NMI per hour, right?
Yeah.
Now, or we can also write it as, I think we should write it as 480 knots mean 480 nautical miles per hour, right?
Yeah.
So 480 nautical miles per hour means 1 over 1 hour, right? So converting this nautical mile thing to kilometers. So how many kilometers in 1 nautical mile? It's 1.83 kilometers. I'm writing 1 nautical mile and here I'm writing the kilometers. The kilometers will be 1.853. Got it?
Yeah.
So nautical mile multiplier cancelled and we're left with only kilometers per hour. So doing this or calculating this. So 480 multiply 1.853, right? So now the speed will be in kilometers per hour, 889.44. Got it?
Yeah.
Now we can use this speed in this formula. The distance is, yes, 2130 divided by this speed, 889.44. Answer must be in hours, right?
Yeah.
So 2130 divided by that value. So we get 2.394748, sorry, in hours. And if you wish to convert into minutes, take the integer part hours and this fraction part can be multiplied by 60. So -2, this is the fractional part, 0.3947 multiplied by 60. So this gives you 27 minutes, 24 minutes almost, right?
Yeah.
Got it?
Yeah.
Yeah. Note this now.
Yeah.
Okay, question 12. It says a sheep is tethered to a post which is 6 meters from a long fence.
Yeah.
So this is actually the fence, and yeah, and the distance between fence and the post is 6 meter, where this sheep is tethered, right?
Yeah.
So the length of the rope is 9 meters. Means this rope has a length of 9 meter. Got it?
Yeah.
So find the
Yeah.
area of which the sheep can feed on. Feed
Yeah.
on means he can the sheep can eat that feed, right? So let's see, making this diagram first.
Yeah.
This is actually the fence, right?
Yeah.
And from this, it's actually 6 meter, right? This post. So this is the post. And sheep is attached with a string, obviously. And obviously, it can tie that string to move away from the post. So the total length must be 9 meter, obviously.
Yeah.
If it is like this one, yeah. The maximum length will be this. This is 9 meter long, right?
Yeah.
And what about this length? This is 6 meters, right? So this is actually
Yeah.
the sheep. So this sheep can move obviously in the circle, the maximum distance it covered, like the maximum area it covers, obviously in the circle, right?
Yeah.
So the circle must be just like this. This is actually a center of the circle,
Yeah.
right?
Yeah.
So you can see that the area it covers will be this. Wait, I'm going to show you. The area cover, it must be this,
Okay.
right?
Yeah.
Not this one, because it's outside of the fence.
Yeah.
So we have to find this area. Got it? So how to find
Yeah.
this area? This is not a complete circle. So yeah, we can make few parts of this because we have to remove the pink region. There's one. This must be removed from the circle
Yeah.
to get the yellow area. Only 9 meters, 6 meter given. Yeah. Okay. I'm just joining the center with these 2 points.
Yeah.
So we have a triangle. And what about this? This is a sector. So if we find the area of this triangle and the area of this sector, right? So we
Yeah.
can add them to find the total area that is bounded by the yellow color, right?
Yeah.
Okay. This is obviously the radius. And it must be 9 as well.
Yeah.
Got it?
Yeah.
According to the circle property, these 2 lengths must be equal. Got it?
Yeah.
So I need actually the base. So I'm using a right angle triangle, this one. The right angle triangle, this. So find this x. X is this length, got it?
Yeah.
Okay, using the Pythagoras theorem here, it will be obviously 9 square. The hypotenuse square is equal to the other two sides are 6 and x. So it will be 9 square minus 6 square is equal to x square. Now taking square root of both sides. So we get the value of x, right?
Yeah.
It is 81 minus 36, obviously, yeah. Yeah, it is 45 inside the square root sign, right?
Yeah.
So this is the value of x. To find the area of the triangle, what we need this total base. And obviously it is 2x. And height is 6, right? So we can just use the formula half times base into height to find the total area of this complete triangle. Got it?
Yeah.
Okay, but we also need this sector area as well. So first of all, we'll be finding the angle to find the sector area. Got it? So how to find? I'm finding this angle.
Yeah.
From this triangle, right? And obviously this must be equal to this one. So if I say this angle is y, this should be y as well. Got it?
Yeah.
Okay. How to find the value y? We have two lengths, 6 and 9.
Yeah.
According to this angle, this length must be adjacent side and this length must be hypotenuse. So that's why I'm using the cos. So cos y will be equal to, I'm applying a cos in this triangle, right? Right angle triangle. Adjacent side, that is 6 over hypotenuse, that is 9. So y will be equal to cos inverse of 6 over 9. Got it?
Yeah.
So we get 48.19.
Yeah.
In degrees. And as I need this angle as well, I actually need this angle, yeah. This is the sector angle. So sector angle will be 360 minus 2y, right? Y plus y, right? 2y.
Yeah.
So 360 minus 2y is 48.19. So we get 360 minus 2 time answer. 263.62. So this is the sector angle. Okay, now we can find the total area of this part, right? So area of which shape can feed on will be equal to this sector area plus triangle area. Area of triangle plus area of sector, right?
Yeah.
So what is the area of triangle? Triangle that I'm using is this, right? This triangle I'm using. So in this triangle, the base is this length and the height is this 6. So 1 over 2 base into height. 1 over 2 base multiplied by height. What is the area of sector? Sector angle or theta divided by 360. This time we have, this is actually the sector angle theta, right? So theta over 360 multiplied by pi r square. What is r? R is 9 here, right? So 1 over 2 base is obviously 2 times x. X is 45, so I'm writing 2 times 45 square. And height is 6. Then plus theta. Theta is, 263.62. Got it? Over 360 multiplied by pi r square. R is 9. So we can calculate this value by using calculator. So half multiplied by 2 times 45 square root.
Yeah.
And then multiplied with 6, then plus 263.62 divided by 360, and then multiply by pi into 9 square. Got it?
Yeah.
So my answer is 226.59
Yeah.
in obviously centimeter square, sorry, meter square. So this is actually the area, required area.